Hi, hello, welcome back to our channel. Now we are going to discuss about thermal properties of matter crash course. It is somewhat big chapter, but it is very easy and interesting also. Don't leave this chapter also. Anyway, come to our topic now. First we are starting with what is the heat. You know that everyone we feel, especially in this summer now also we feel so hot like that. So what is the heat? Heat is a form of energy. Heat is a form of energy. Then how to measure that heat? Just now I said heat is energy, means the unit is the joules, but heat we are expressing in terms of calories also. Calories is the unit in CGS system and joule is in SI system, and you remember that 1 calorie equals to 4.2 joules. 4.2 joules. Then come to temperature. What is the temperature? Temperature is the degree of hotness or coldness of the body. So that is any even suppose it's too hot like 100 degrees centigrade. We are expressing that, we are measuring. Temperature is a measurement. How much hotness is there, how much coldness is there, everything we can express in terms of the temperature. But how to measure the temperature? For measuring the temperature, we should require thermometers, but there are different types of thermometers. But the basic things is, what are the basic things for measuring the temperature? We need the scale and we need one medium inside the scale. Nothing but we can call that entire instrument is called the thermometer. First we should focus on types of the scales and what are the basic methods they are following to measure the temperature. So in this there are different scales are there. First one is the centigrade scale, or you can say that Celsius scale also, centigrade scale. Then Fahrenheit scale, Kelvin scale. Mostly we are using these scales, and if you want to introduce your scale also you can introduce. Then another one is the Ramer scale also we are taking, Ramer scale. But what is the basic thing for measuring the temperature is we require the scale, but how to calibrate the scale, that is the main thing we are taking. One is the lower fixed point, LFP. Another one is the upper fixed point. This is the upper fixed point. Actually you can take this one. This is the freezing point of water, freezing point of ice you can take it, and this is the boiling point of water we are taking. Generally for centigrade scale they have taken that 0 degrees centigrade is the freezing point of ice, boiling point of water is 100 degrees centigrade. Suppose the question is what is the lowest and upper fixed point in centigrade scale, means immediately you can go through the lower fixed point is the 0 degree centigrade, upper fixed point is the 100 degree centigrade. Now how many divisions are there? We can divide this scale into 100 divisions. Each division carries 1 degree centigrade, 1 degree centigrade. So here you can take it, suppose we want to find out the x, means like C minus, how to measure the temperature means C minus, here C minus lower fixed point is how much? 0. Upper fixed point is how much? 100 degrees centigrade. So the difference is how much? 100. C minus 0 by 100. When we can go through the Fahrenheit scale, lower fixed point is the 32 degree Fahrenheit. He took that freezing point of that ice is 32 degrees of Fahrenheit, and upper fixed point is, you should remember these values, 212 degree Fahrenheit. The number of divisions are how much? 180. So each division what we are saying 1 degree Fahrenheit. So here what we are writing, F minus 32 by how many number of divisions are there? 180 divisions are there. When you can go for Kelvin scale, this is the 273 is the lower fixed point degree Kelvin, and 373 is the upper fixed point Kelvin. So here you can take it K minus 273 by 100. And you remember that in this case, in the case of Kelvin scale, number of divisions are how many? 100. In Celsius scale also same. That's why what we are saying in Kelvin scale and centigrade scale, both the length of the scales are same. Then Ramer scale is the 0 degree Ramer and 80 degree Ramer. So you can take it R minus 0 degree by 80. So if you want to find out the centigrade scale, how to equal this one? Just you can put one equal symbol here. You can equal these two with the help of this formula. Then how to find out the relation between centigrade scale and Fahrenheit scale? You look here first thing. See, when we are taking these two scales, C by 100 equals to F minus 32 by 180. After simplification, this is 5, this is the 9. Suppose if C equals to 40 degrees centigrade, same value in Fahrenheit scale, what is that value means? How to find out? Instead of C, we are writing 40 by 5 equals to F minus 32 by 9. This is the 8, this is the 72 plus 32 is the this value, then F equals to how much? 104 degree Fahrenheit. See, 40 degrees centigrade is on centigrade scale, but same value in terms of Fahrenheit, that is the 104 Fahrenheit degree. Suppose sometimes they are asking question, same value on the centigrade scale and Fahrenheit scale, means what we are taking? Instead of C, we are taking x by 5 and here x minus 32 by 180. After simplification, you are getting x equals to minus 40. You can say in terms of F or in terms of centigrade, like that. Like that, how to give the relation between Fahrenheit scale and Kelvin scale? Same, F minus 32 by 9 equals to K minus 273 by 100. So if you are, suppose they are giving K value is the 373, like that. 373 minus 273 is the 100. Then F equals to 32 plus 9 is the, you are getting 41 degree Fahrenheit. Like that, you can give the relation and you can convert the temperature from one scale to the another scale. Not only this one, how to give the relation between centigrade scale and Kelvin scale? See, C minus 0 by 100 equals to K minus 273 by 100. So 100 cancel. Suppose C equals to K minus 273. Then K equals to how much? C plus 273. Especially in the case of gas laws, Boyle's law, Charles law and ideal gas equation, we are using the absolute temperature. Suppose they are giving 27 degrees centigrade, but while we are applying that laws, we must convert centigrade scale into Kelvin scale. How it is possible? We are adding that C value to the 273. Suppose C is the 27 degrees centigrade, means 27 plus 273, we are getting the 300 degree Kelvin. So this is the only one thing we have completed. For constructing the thermometer, these are the scales and this is the calibration of the scales, and we require one more parameter to measure the temperature, that is the medium. Without that also we can't find out the temperature. So generally there are different types of thermometers: volume thermometers at constant pressure, pressure thermometers at constant volume. And you remember that when constant pressure only we can find out that in terms of volume. When volume is constant, we can express in terms of the pressure. Like that, when you are using the platinum, that is called the resistance thermometer. For all these things, the basic formula is, look here, C equals to, if it is volume thermometer, means pressure is constant, so we can take it Vt minus V0 by P100 with respect to 100. This is at T degree centigrade, this is at 0 degree centigrade volume, this is the volume at 100 degree centigrade, and we are taking Vt minus V0 by, here also V0 into 100. Same thing, suppose in terms of pressure, means volume is a constant, you can write it Pt minus P0 by P100 minus P0 into 100. Like that. This is in terms of pressure. Like Pt is the pressure at T degree centigrade, like 100 Pascal. This is like 50 Pascal. Means you can able to find out the temperature. Here you are getting the, this is the T, means temperature in terms of, with the help of the volume, with the help of the pressure, and with the help of the resistance also we can take it. See, RT minus R0 by R100 minus R0. RT is the resistance at T degree centigrade and R0 is the resistance at 100 degree centigrade. Like that, in terms of length also we can find out, especially in the case of mercury thread. So length at T degree centigrade minus length at 0 degree centigrade by L100 minus L0 into 100. Anything you can find out. One problem also we are doing here, if LT equals to 20 centimeters, then L0 equals to like 10 centimeters, then L100 is the 5 centimeters. Find the temperature, means what we are taking, T equals to, here 20 minus 10 is the 10, Then 100, at 100 means this is the 5 and L naught is the 10. So what we are taking, 5 minus 10, how much it is? Minus 5 into 100. After simplification, you are getting T equals to minus 200 degrees centigrade. Like that, they are giving resistance also at RT and R naught. We can use this one, and you can able to find out this one. So there are different types of, and alcohol thermometers also it's there. For like 0 degrees centigrade, 0 is the freezing point we have taken, but lower temperatures, minus 20, minus 100, minus 200 means we can go through the alcohol thermometers. Like that, there are different types of thermometers and different ranges are there. This is the theory once you can read from the synopsis. Now we are going to discuss about our chapter name is the thermal properties of matter. We know that matter exists in nature 3 states. One is the solid, another one is the liquid, then third one is the gaseous state. First, suppose we are increasing the temperature of the body. In the case of solids, we can observe generally, we can observe that expansion. But how it is expansion? We can calculate that along the lengthwise, if it is having 2 dimensions of that body, area or superficial, then if it is having the 3 dimensions, we can express 3 dimensions of expansion like that. But the basic thing is what? When you provide the temperature, the body will expand. Okay, if you are taking thin wire, only lengthwise you should observe. If you are taking one plate, 2 dimensions it is having, length is increasing, breadth is increasing, entire thing we can express that areal expansion, like that volume expansion. Then come to first one, this is the linear expansion. This is belongs to expansion of the solids, linear expansion. Linear expansion. Suppose L1 is the length at T1 degree centigrade, L2 is the length at T2 degree centigrade, and delta L is the change in length. This is the change in length. Then how to write this one? See, you know that change in length is directly proportional to original length, and change in length is directly proportional to change in temperature. Suppose you take this is the one wire and this is the another wire. Here also I am applying 30 degrees centigrade. Here also I am applying like 30 degrees centigrade. Where you should observe more expansion depends on the original length also. If more length is the more expansion. That's why here I have given that this is the relation. Then come to next one. When you combine, you are getting one proportionality constant alpha into L1 by delta T. So these two are this is the directly proportional to this one. So when you are combining, delta L equals to alpha into L1 into T1. From this, alpha equals to how much? Delta L by L into change in temperature. Instead of L1 we can take the L also. From this you can express this one, L2 minus L1. From this, look here, L2 minus L1 equals to L1 into alpha into change in temperature. If you want L2, how can you take it? L1 into 1 plus alpha into change in temperature. So with the help of these expressions, we can able to find out the alpha, we can able to find out the L2, and anything we can able to find out the change in length, we can able to find out the change in temperature. This is called the alpha is called the coefficient of linear expansion. This is called the coefficient of linear expansion. Not only this one, where we should express this one, in the case of thermal stress. You know Young's modulus, what is the formula? F by A delta L by L. In terms of temperature, because of the temperature, this length is changing means immediately F by A is the thermal stress. Y into, instead of delta L by L, what we are taking just now, you know that delta L by L is the alpha into change in temperature. Alpha into change in temperature. So don't fix this one. If you know the Young's modulus and stress and delta T, we can able to find out the coefficient of linear expansion. This unit is what? Per degree centigrade. Not only this one, look here. Suppose one wheel is there, some cave type we are taking, inside gap is there. Initial radius is the R1. After increasing the temperature delta T, this radius is increasing how much? Delta R. Here how to write this one? See, delta R equals to R into alpha into change in temperature. Suppose we should consider the diameter. delta D equals to D into alpha into change in temperature. So anywhere we can observe this one, not only this one, for bimetallic strip, two materials we are joining like this. What is the application for this? Suppose some medicine, some syrups are closed in that one material, previous they are using the glass and they are closing with aluminum foil type. Why? Both are having the same expansion. In summer, no, both are expanding same means then there is no inserting of that gas. The gas is not going inside. There is no spoiling of that medicine at that one. So this is the bimetallic step. Look here. Whenever we are increasing the temperature, how much? Delta T. Then del L2 minus L1 is also constant. Change in temperature is same. Suppose here we are giving 20 degrees centigrade, here also 20 means. So change in length is also same, means that condition will applicable only for L1 alpha 1 equals to L2 alpha 2. From this you can write it L1 by L2 equals to alpha 2 by alpha 1 also. Not only this one, in the case of clocks, you know the time period, what is the formula? 2 pi into under root L by G. 2 pi into under root L by G. From this what we are writing? Delta T by T equals to, when G is constant, we can write it 1 by 2 into delta L by L, percentage error. Then instead of delta L by L, we are taking simply 1 by 2 into alpha into change in temperature you are taking. So like that, this is belongs to the completely linear expansion. We are taking one wire, L1 is the length at T1 degree centigrade, L2 is the length at T2 degree centigrade. We are using this concept. Now we are going to discuss about two-dimensional expansion, or that is called the aerial expansion. So same thing, but we can take it. A1 is the area at T1 degree centigrade, A2 is the area at T2 degree centigrade. We are taking this one. So in this case, we are getting the coefficient of aerial or superficial expansion. So it is represented by beta. So this beta, what you are getting, that expression beta equals to A2 minus A1 by A1 into change in temperature. Instead of this, we can take it change in area by A1 into delta T. From this, A2 equals to, we are writing A1 into 1 plus beta into change in temperature. There alpha we got it, but here we are taking beta. So like that we can use this one, and you can find it A2, A1 and all this. From this A1, how to express this one? A2 by 1 plus beta into change in temperature. At the same time, you remember that relation between alpha and beta is alpha equals to beta equals to 2 times of this alpha. The next one is the volume expansion. Volume expansion, and coefficient of volume expansion is represented by gamma. Same thing here, you are taking gamma equals to. So this one we can use in the case of bulk modulus also. Bulk modulus, you know that K equals to F by A into F by A divided by delta V by V. From this, F by A equals to K into, instead of this is aerial, no, this bulk modulus belongs to, this is the volume expansion, here it is coming. So this is the change in volume by original volume into change in temperature. So V2 equals to V1 into 1 plus gamma into change in temperature. Then it should be right, V1 equals to V2 by 1 plus gamma into change in temperature. And you know that generally in the case of liquids, volume is inversely proportional to density. In terms of density also you can express this one. But anyway, you can express this is in terms of bulk modulus also. You know that stress equals to K into delta V by V. Instead of delta V by V, what we are taking? Gamma into change in temperature. So like that we can able to find out. Suppose you are taking another cube. Along the x-axis, y-axis, the linear expansions are different. Along the x-axis it is alpha x. Along the y-axis it is alpha y. And along the z-axis it is alpha z. Then how to find out the alpha here? Average of all three. We are taking alpha x plus alpha y plus alpha z divided by 3. Then you remember that what is the relation between alpha, beta and gamma? It's very important. Alpha is, beta is, gamma equals to 1 is to 2 is to 3. Means gamma equals to 3 alpha then beta equals to 2 alpha. When we are taking this ratio, what we are getting, gamma by beta equals to 3 by 2 times of that. So this relation is very important. Finally, we should observe that there are three types of expansions: linear expansion, areal expansion, and volume expansion. Linear means only lengthwise we can observe. That area means like 2 dimensions we should consider. Volume means we are taking 3-dimensional expansions. So we can go through the another part also. It's somewhat big chapter. Next part I want to teach you what are the expansion of liquids and gases also.